all of the code is available in full access inside of those libraries. So you have complete access to all the controls in source, so you can make modifications as you need to, and then use those tools to just tweak how what gets passed into the functions.
Hello, folks. Welcome to Embedded Toolbox, the show where we here at Embedded Computing Design solve one engineering problem at a time. My guest today is Clark Jarvis of Infineon, and we're going to be talking about the ModusToolbox, which can actually solve several problems, but we're going to focus on some of the key ones today. Welcome to the show, Clark.
Yeah, thank you, Ken. Yeah, so it's kind of said, like, we're looking at how do we solve problems today, specifically looking at how do we get an embedded product to market and how do development tools really kind of factor into that. So we're going to look at ModusToolbox and kind of break it down into a couple of key aspects that really help you get your product to market, go all the way from kind of getting started to getting the product out the door.
Awesome. Before we jump into the live demo, can you give us sort of a rundown of the capabilities of Modus and how that works?
Yeah, absolutely. Yeah. All right, so ModusToolbox itself really is a development ecosystem, right? It's more than just a tool here or there. I like to describe ModusToolbox really kind of broken down into two main aspects, right? We've got development tools themselves. These are going to be the things that you install and use on your desktop. And then there's all of the runtime software, everything you use to create the latest and greatest application. ModusToolbox is a collection of all of these comprehensive resources. You can see in this block diagram, right? From working the bottom up, we've got BSPs that target the various devices that come from Infineon. You're going to have all types of middleware, everything you need to create the latest Internet of Things type product or some type of industrial product. To help get started, you're going to have code examples and reference designs and use case demos really to serve as kind of a starting point. And then built on top of that are all of the tools that you use. And we're going to look at quite a few of these today. We've got tools like Project Creator, Library Manager, the IDE itself, whether you're using an Eclipse-based IDE or one of the other supported IDEs like VS Code, IR, or Kyle. We've got configurators and tuners that are all there to help you kind of take the complexities of these devices and boil it down into these nice little UIs that help you set it all up. And ultimately, the underpinning of all of this is a Git and a make-based build system. And we'll explore kind of the value of what that brings to your embedded development. So when you're working with ModusToolbox, we'll have a dashboard, we'll show that, and that's going to kind of provide an entry point to kind of get you started. But once you get that project created, you get all of those pieces up and running, we live in this kind of edit, compile, debug cycle. We're working inside of an IDE, we're making modifications to our project. This is the typical stuff that we deal with when designing and creating an embedded product. But we're going to have these other aspects that are related to ModusToolbox to really help facilitate that. We'll have library level configurators that help you manage and set up Bluetooth and USB type products. And then down to the actual hardware itself, where we're dealing with BSP level configurators, library managers to be able to pull products in. And all of this is connected through GitHub repositories. So you always have the latest and greatest content. But what I wanted to focus on today, especially as we get to how do I really make embedded development efficient, is looking at these kind of four key aspects that I really feel ModusToolbox plays well into. The first one's going to be the development flow itself and the flexibility of the development. As I'm creating applications, I want to use this really cool middleware, these building blocks that exist in our industry. How do I take advantage of those and get them into my actual product? And then when I get down to the actual coding of the project itself, right? What are the function calls that I'm using? What are the APIs that I'm using? And at what level? So we'll explain the various levels that you can take advantage of and the benefits and trade-offs of those. And all of this ultimately is really leading up to kind of the application portability, right? The ability to take an idea, a concept, to prototype it, do some development on a development kit or evaluation kit, but then ultimately get it over into the real hardware. So we'll talk about some of the aspects and features that really aim to make that as smooth as possible. We'll start with the dashboard itself. So this becomes kind of a easy starting place for ModusToolbox. It has tons of resources that you can use to learn more about it, get access to documentation, training materials, and videos. But what I'd like to highlight in here is this idea of which IDE do I want to work with, right? Because we're talking now about the development flexibility. If you kind of envision that hardcore develop engineer, right? And you say, how should you develop? How is the right way to develop an application? They're going to say, well, the way I do it, it's right. And he's right? Being able to have an environment that meets my needs, that's what's going to make an engineer successful, because they can configure this and use it the way they want to. So you can see options here, like, do I want to use the bundled Eclipse IDE that comes with it, or do I want to work with Microsoft VS Code, use IR's Embedded Workbench, or ARM MDK? These are all the options that are built right into it, even including an option of saying, you know what, I don't want to use one of these IDEs. I'm going to pull up Emacs or just a code editor and just do everything on the command line. And all of that's possible. In fact, the command line itself is quite a powerful way to use ModusToolbox. It allows you to integrate it into automation, continuous integration systems, or build systems, source code repositories. There's so much you can do when you have access to a build system that is able to facilitate command line. And all of this is based on effectively a make-based build system. So just typing in make help, we see we got tons of details about how I can use it. I've got access to integrating this into continuous integration or building it. I can even launch my project directly inside of VS Code, directly from the command line. That'll pull up the application. You can see I've got my application here, access to all of my source files. There's even a really cool ModusToolbox assistant that was developed by someone in the community that provides a lot of the ease of use that comes along with ModusToolbox. Because one thing that we don't want to force somebody into is saying, hey, you've got this really cool tool, but you've got to build it all from scratch, right? So there's a lot of ease of use that comes in tools like VS Code. We provide an Eclipse-based IDE that has a lot of these ease of use capabilities built into it, right? So you not only do you get the flexibility, but you get an easy to use application as well. So kind of transitioning from the various options you have with a very flexible development environment, let's look at now, how do I manage the middleware that's in my application? So I've got a really basic application that's opened. And inside of ModusToolbox, you'll see this quick panel with all of the access to various tasks and things that we work on, including various tools that we can launch. And one of them is called Library Manager. Library Manager itself, it allows me to bring in those various building blocks that come from various source code repositories that are provided by Infineon, or they may be provided by some of Infineon's partners. And we can see in here, I'd like to add a library. This will pop up a new dialog where we see this vast amount of libraries and middleware that's available inside of ModusToolbox. And let's say for this example, maybe we wanted to add some connectivity, Wi-Fi connectivity. Come up here to the Wi-Fi section, and I'll put a check mark into this. I've got some details about what it is. And as I bring that into my project, it's going to figure out, okay, here's all of the dependencies you're going to need. You're going to need lightweight IP, embed TLS. So all of these foundational or these dependency libraries that you're going to need, pull all those in and take care of it for you, and it'll update into the project. The other useful aspect of the library manager is being able to handle the specific versions. So you'll notice here, I've got two libraries that actually have these little green arrows. This is an indicator that says, hey, there's a new version. Infineon has come out with some release, right? Some new feature capability. And I can manage that. I can say, yeah, I do. I want to upgrade to the latest release, or no, this is a solid code base. I don't want to disrupt anything. I'm sticking with the library that I have now. So those are the kind of the ideas that allow you to integrate these libraries into the application. And there's details about how to actually do the integration, or how to utilize it inside of your product. So A lot of great information all built into the tool. So for my project, I'm not actually going to make any changes to it, but I did want to highlight specifically these two libraries, these HAL libraries and PDL libraries. So say, yeah, we don't want to make any changes to it. So the HAL library and the PDL library are kind of the fundamental libraries that are going to give you the APIs and the function calls to interact with the hardware. And these are the various levels of APIs that we have. And we have documentation built right into the tool. So in the quick panel, I can scroll down and say, I'd like to see more information about this hardware abstraction layer. So that's what the HAL is. It's an abstraction of the actual APIs that we use. And so I opened up the documentation for that. I can come down and I'm going to look at a PWM. So we'll look at the simple PWM example. We've got some quick start. We've got some reference code here that we could cut and paste and use in our project. And it's pretty simple API, set of APIs, right? We're going to initialize our PWM signal. We're going to set up some parameters like the duty cycle for it. Then we're going to kick it off. We're going to start it. And so that's the idea around the hardware abstraction layer. I can take this same code and I can run it on any one of the devices supported in ModusToolbox, whether it's a PSoC 6 device, an XMC Industrial Microcontroller, TRAVEO automotive device, and I'm going to get the same behavior. But sometimes I may need to have a little bit more granular control, right? I need to go a little bit lower level than that. And that's what these lower level, peripheral level driver libraries are. So I'll click on the documentation for it as well. Bring that over. And here we're going to see not that we're working with like a PWM, right? Because that's more of a conceptual of what we're trying to accomplish. But in this case, now we're going down to a low level. We're looking at the actual IP that's on the device itself. We're working with the, in this case, the timer counter PWM IP or module. And very similar, though, we can see the type of code that's needed to be able to exercise this device. You see there's a lot more, right? Now I have this huge configuration structure with all the knobs and dials, effectively all of the registers that are associated to this particular IP are now exposed and available inside of these function calls. Then when we get down to actually using it, it's not too much more difficult, right? I'm going to initialize it based on this structure that's there up above, enable it, and then kick it off. So not terribly a drastically different API, but it is targeting the actual hardware itself. And you can see that again. I have that replicated here in my project. Here's the PWM-based implementation using the HAL APIs. So again, I have my initialization, setting some parameters and starting it. And then the same implementation on a different pin, but now using the PDL drivers. So you'll also notice, right, here's this big block of code, right? These are all the configurations, and that's a lot. Like, so how do I make that a little bit easier to figure out what are all of these aspects? Because I don't want to have to figure that out. And that's where the additional tools like the device configurator come into play. So this is the configuration for that project where I've got my TCPWM, that's the IP that's used to implement a PWM. I've got it selected, but now I've got this nice UI that's got little tooltips to tell me how I can set up different things, what are the different run modes, the alignment, the periods. And this is where I populate this information, and then it generates that code for me. So you don't have to learn how to populate all that structure. Use the UI, and it'll generate it for you. And so that really feeds into the best practices or how to use these different API levels inside of an application. And you can mix and match them as well. So for instance, if I've got one signal where, all I need is a simple 50% duty cycle running at some period, and that's it. So you use that, but then I've got this other timer where I've got to have really tight control over that. I've got to be able to specify kind of its chain reaction and its dead cycles and all kinds of things. Then I can use a separate instance of this TCPWM and use PDL. So you get to mix and match those drivers to really create the most efficient code for your application. Now, the other thing as we get into more the portability aspects. You'll notice here in my code, you don't see me referencing, port 12, pin 1, or kind of the actual hardware specific declarations. I'm using very friendly terms like my PDL PWM. Up here, I'm using PWM pin 1. That was also shown inside of this device configurator where I can provide these resource names. And by specifying names inside of the tool, these now become software macros, software defines that if I use them in my application, I can change the underlying hardware. I can remap it to a new location. And I don't have to touch my actual application code because it's using these macro defined terms. And so this kind of feeds into the next and then the last aspect that I want to talk about with the concept of a board support package. So everything you see here in this tool, this kind of gets wrapped up along with a lot of other aspects of the hardware itself, gets wrapped up into what we call a BSP, or a board support package. And even within my application, I can have multiple BSPs and kind of switch back and forth between them. And with each of them having a unique pinout or a unique hardware that they're actually running on. And so we'll kind of show that as well. So you see an instance here, right, where I'm using my PWM. That's where those get defined. So if I go back to my project, if I were to compile this, it's designed to run on a very specific hardware, but I can change that. And we see that inside of the library manager, which looks like I closed. Let me reopen it real quick. So you can see here in the library manager, I have multiple BSPs. So these could be different boards, my own custom hardware. And by selecting these, I can tell the project to say, okay, this is now the implementation that I want to use. So remap all of those signals that we talked about to the actual physical pins that are on this particular board. So it makes it very easy to manage kind of one application targeting multiple versions of the hardware or development hardware versus actual product hardware. So the last kind of puzzle piece to this is then how do I create these custom BSPs? And to support that, there's one additional tool that we'll highlight here that's a BSP assistant. So this is really meant to be a tool that guides you down the path of creating that configuration for your hardware. You specify the exact package type that you want, the exact device that you're using. You come in and you can associate, well, this is the device configured file, right? That mapping of the resources to the actual pins that's unique to this BSP. And then you can say, archive this off, and you can actually even use this to create lots of examples or bring it into your particular example. So that's the idea behind all of this. Again, the whole kind of purpose was to show the flexibility of the development workflow, how I can bring middleware in and out very easily and handle the version control when I'm developing code, right? The different levels of API they can use, and then all of that culminating into how do I take my application and move it to actual hardware. So hopefully this provides an overview of these aspects of ModusToolbox, and really the kind of tagline I like to have with this is we want it to develop the way you want to develop with a workflow that you get to define.
That's awesome, Clark. Thank you so much for walking us through ModusToolbox there. One question that I did have is obviously it's generating a lot of the code and code examples as you go through. If one of the engineers wants to get in and start customizing or mucking with the direct code, I assume they can do that too if they want.
Yeah, absolutely. In fact, that's something that's probably worth explaining is when we were looking at device configurator and the code that it was generating, really what it's generating is it's generating those configuration structures. All of the code is available in full access inside of those libraries. So you have complete access to all the controls in source. So you can make modifications as you need to, and then use those tools to just tweak how what gets passed into the functions. So,
awesome. What code languages are preferred or?
Yeah, so it's primarily set up to do C programming. That we do have some of the source code and libraries are using C++ as well, so it supports both of those.
Sure. Awesome. That is about all the time we have, Clark. Obviously, there's a lot more with ModusToolbox that folks can play with. Where can folks find out more about it?
Yeah, the best place to go to is infineon.com/ModusToolbox.
Spectacular. Thank you so much for being our guest today on Embedded Toolbox, and thanks to Infineon for showing us the ModusToolbox.
Yep, Ken, thank you very much.
All right, folks, make sure that you're liking and subscribing if you're watching this on YouTube, and checking out all of our other shows. I have been Ken Briota of Embedded Computing Design and your host, and we look forward to seeing you next time. Once again, thank you so much for joining us, Clark.
Thank you.